Okay, clustering. Okay, this connects back to what I said before, that locally all of these structures are branching networks. I need to drink a lot more. Okay, so this is the Newman's clustering coefficient. So this is the number of triangles divided by the number of triples with a 3 to clean up the fact that each triangle closes a triple. And it can be interpreted very nicely in this way. We have a node, has two friends. What's the probability that they are connected? And that's our C2, if we average over everything. All right, so if we're randomly making these things, then it's going to be that, and we're using that first construction method, C2 has to be P, right? It just has to be the probability that you connected these, because it's independent of these guys, right? So, and as we saw for large N, right, we want to have an average degree that remains the same. So as we look up, as we go to larger and larger networks, then this P goes to 0 as 1 over N. So the number of, the chance that you even see a triangle goes to 0. And you'll start to see that if you sort of move further out and ask the same questions, right? This one does have friends, right? There's an infinite number of others to connect to, or a growing number to connect to. So it's going to be connected on average to some of them. Be a little bit careful about the average number of friends this one will have. We'll get to that. But this will start to look more like a tree, right? And the loops that you get will be long. The cycles will be long cycles. So that's just a hard thing to deal with. Okay, so, right. Okay, and that is the story. So locally, these things look like branching networks, which is going to help for our calculations for how things spread and so on. And the sneaky thing that people have been able to do over the years, and we'll see that in fact it's better to eventually really dive into the heart of these things that have loops and so on, is to say, let's take the giant component and just leave that by itself, and we'll examine all of the other ones. And because they're finite, then they will actually be pure branching networks. There's no chance that they have some loops inside them. And we can study them exhaustively, and then we'll say everything, so it's like a negative space thing, right? We'll say everything about everything that is not the giant component, and then we can talk about what the giant, what its size is in particular. So that's some trickery, but we'll see that in fact you can go right into the giant component, which is pretty spectacular. All right, pure branching networks, yes. No small loops. All right, that's good to know.